Good morning to all. Today we are going to discuss some of the designing procedure for FIR filter design using windowing technique. So first one is we have followed the step by step. The first step is the specification of digital FIR filter. As first one is how to find out the desired frequency response. This is namely called for HD of e power j omega in mathematical notation, then equal to c into e power minus j alpha omega. Here c is the constant. We are getting the normalized magnitude value is 1. So we can represent for ht of e power j omega equal to e power minus j alpha omega. Here alpha is a representation for n minus 1 divided by 2. So n is nothing but your length of the filters, right? So the second point is the cutoff frequency omega c, omega suffix c. This is the angular velocity of cutoff frequency for low pass filter and high pass filter, and omega c1 and omega c2 for the band pass and band stop filters. So here, so we are going to design analog filters. The cutoff frequency is fc and the sampling frequency is fs, and also specified then calculate the cutoff frequency in digital filter using for the formula omega equal to 2 pi f. So f is replaced by fc divided by fs. So fc is nothing but a cutoff frequency, f is nothing but your sampling frequency. Then we have to find out the number of samples of impulse response. That should be capital N, representation for capital N. So the step 2 to determine the desired impulse response, that should be mathematical notation is HD of N. By taking the inverse Fourier transformation of desired frequency response of HD of e power j omega. So this is a mathematical formula HD of n equal to 1 by 2 pi the integral of lower limit minus pi to plus pi HD of e power j omega into e power j omega n into d omega. Then we go for the step 3, choose the desired windowing sequence omega n. So here we have a lot of windowing techniques are available. So for example, rectangular window, Hanning window, Hamming window, Blackman, Kaiser, triangular, Bartlett. So all the methods we find out the filter coefficients. Okay, so then first we should find the suitable windowing technique. Then we go for the step 4 to find the impulse response of h of n of the filters. So we are calculating for the n samples of the impulse response for n equal to the variable values from 0 to n minus 1. So the impulse response formula is h of n equal to ht of n multiplication with window function. So the here window function is rectangular window or Hanning window or Hamming window. So depends upon the windowing technique, right? So now we are going to calculate the impulse response is symmetric. The center of the symmetric at n minus 1 divided by 2. So we are using for the symmetric condition is h of n equal to h of n minus 1 minus n. We are using this formula. We can find out the half of the symmetric condition coefficients, right? Then we go for the step 5, the transfer function of h of z. We are taking the z transformation of the impulse response h of n. We will get h of z of the filter. So h of z equal to summation of the fundamental formula is summation of n equal to 0 to n minus 1 h of n z power minus n. So final step is realization technique for FIR filter. So draw the suitable structure in realization in FIR filters. So this is the most important designing procedure for FIR filter for all the windowing technique. So next class we are going to discuss the frequency sampling technique. Thank you.